Hello everyone and welcome back again. Today we're going to talk about thirds. I know a lot of students hate this topic, but I'm going to make it easy for you. Now let's solve this interesting question right on our screen. The question reads, simplify and express 1 over 1 plus root 432 minus 3 root 48 plus root 27 in the form of p plus q root 3. So this form simply means that we are going to simplify this third to its lowest terms, right? So it has to be in its lowest terms, and let's see how far we can go with this. When simplifying, we have to ensure that the third is simplifiable. Now the question right now is this third simplifiable? Yes, it is. It is simplifiable because we have big numbers here as irrational numbers, right? Here we have the square root of 432, and we also have the square root of 48. The question right here is, how am I sure that I can simplify the square root of 48? It is simplifiable. Yes, it is, because the square root of 48 can be written as the square root of 16 times 3. Yeah, and we know that the square root of 3 is irrational, which means we cannot simplify it any further. But 16 is a perfect square, which means we can always get the square root of 16 and simplify this further. So one cool trick you need to have at the back of your mind is, whenever you are simplifying thirds, you must look out for big numbers. Okay, from big numbers you can obtain perfect squares that will help you to simplify the expression further. Now let's solve this question to see how it is. Now here we have our solution. Right here we have 1 over, we have 1 plus, then this 432 can be written this way, 144 times 3. Yeah, because 144 times 3 is equivalent to 432. We have not changed anything yet. We only broke it apart or split them apart so that we can obtain perfect squares that help us to simplify the expression. Okay? Now here we have minus 3. Now this 48, like we mentioned earlier, can be written as 16 times 3. Okay? And then finally, 27 can also be written as 9 times 3. Now, look at the connection here. 144 is a perfect square, 16 is a perfect square, and 9 is also a perfect square. Now, you've seen the connection. So that was where I said whenever you're dealing with big numbers, all you need to do is to find a way to break them apart so that you can find perfect squares. That's a very important secret that you need to know. Now, let's proceed. Here we have 1 over 1 plus, now 140, we can now split them apart this way and write them this way. 1 root 144 times the square root of 3. Okay, remember that they are all in the same square root, so you can split them apart and they will now carry separate roots. So we have minus 3, and here we now have root 16 multiplied by root 3. Okay, and finally we have plus the square root of 9 multiplied by the square root of 3. Okay, now let's simplify them right now, having split them apart. Down here we have 1 plus the square root of 144 is 12, so this now becomes 12 times the root of 3, then minus the square root of 16 is 4, so we now have 3 multiplied by 4, okay, times root 3, then plus, here we have 9, the square root of 9 is 3, and this is multiplying root 3, okay? You see now, we're able to break these big numbers apart, and we finally found perfect squares. That's the goal of simplifying thirds. So let's proceed to clean this up. We have 1 over, down here we have 1 plus So 12 times root 3 gives us 12 root 3, okay? So this 12 is being attached to the 3. It simply means that they are multiplying. Minus 3 times 4 gives us a 12. So 12 times root 3 is 12 root 3, okay? And then 3 times root 3, this gives us plus 3 root 3, okay? Now, when it comes to addition or subtraction of surds, we only consider, in most cases, if you want to find out like terms very easily, you consider what is inside the root, okay? Here we have a 3, and here we have a 3, okay? This root 3 are both attached to these numbers. One is a plus, one is a minus. As long as the numbers, I would say in this case, inside the umbrella. Let me use umbrella for easier understanding. So when you see something like this, okay, this is a 3, this is a 3, they are the same, okay, on both times. What you do is you add them up. But suppose you have a root 4 here. Let's say you have 12 root 4, and the other one is 12 root 3. You can't add them together because they are not the same, okay? So you now have something like x and y. But in this case here, if it's a root 3 and a root 3, or root 4, root 4, root 5, root 5, as long as they're the same, okay, as long as the two umbrellas, let me use umbrellas, are the same, or as long as the two irrational numbers are the same on both sides, you can easily add or subtract them. So now 12 root 3 minus 12 root 3, they cancel out, they're equal to 0. You just drop them because they are like terms. So now we are left with 1 over, what is remaining down here is 1, then plus 3 root 3. Okay. Now the question here is, have we arrived at our final solution? Remember, they say we should express them in the form of p plus q root 3. Have we arrived at our final solution? No, we've not. So what we have to do right now is to rationalize the denominator by multiplying the numerator and the denominator by the conjugate of the denominator. I say again, whenever you want to rationalize the denominator, you must multiply the top, which is here, and the bottom by the conjugate of the denominator. Now, why am I doing this? It is not proper to leave the denominator of any fraction in surd form. You can see that this right here is an irrational number. So we cannot leave this irrational number at the denominator. We must find a way to remove it, and therefore we must multiply the top and the bottom by the conjugate. The conjugate simply means changing the sign, okay? If you have a plus down here, when you take the conjugate of this denominator, you simply change it to a minus, okay? So this is now going to be, let me write it here properly. We have 1 minus 1 plus 3 root 3, okay? And then we now have multiplied by 1 minus, have you seen? So it has been changed to a negative, and that is the conjugate of this denominator. We have 3 root 3 over 1 minus 3 root of 3. Then I'm now going to expand them. So 1 times 1 is a 1. Then 1 times minus 3 root 3 gives us minus 3 root 3 over 1 again times 1 gives us a 1. Then 1 times minus 3 root 3 gives us minus 3 square root of 3. And then 3 root 3 times 1 gives us plus 3 root 3. And finally, 3 root 3 times 3 root 3. See how to multiply this, okay? Now you do it this way. Outer, this one is the outer term. You say outer for outer, and then inner for inner, okay? Don't make the mistake of multiplying randomly. It follows the process, and you must understand that. So we say, now the outer terms are 3, okay? The outer terms are not inside any root, right? So we just multiply them together. Don't say outer inner. Don't go and say this 3 here times the 3 inside the square root gives you root 9. Don't do that, please. It's only outer, outer, inner, inner. So 3 times minus 3 gives us minus 9, and then root 3 times root 3, okay? Like I said, inner, inner, outer, outer. Then root 3 times root 3 can be written as the square root of 9. Let's just leave it this way and continue from here. I'm going to simplify that further. Now on top we have 1 minus 3 root 3 over, down here we have minus 3 root 3. Remember what I told us when I was simplifying? We look at what is inside. Here we have a root 3. Here we also have a root 3. They are simply the same. So one is a minus, you can see, minus 3 root 3. And this one is a plus 3 root 3. They are both equal to 0, so you can cancel them out. And what are we left with? 1 minus 9. And here, the square root of 9 is 3. Okay, so we can simplify this further to be 1 minus 3 square root of 3 over, now 9 times 3 is what? 27. So we have 1 minus 27. Simplifying this further, we have 1 minus 3 square root of 3 over 1 minus 27 is negative 26. Okay, so we can see that there are two terms on the denominator. This one is the first one, and this is the second one. Okay, so we can now break them apart since they have a common denominator. And this is now going to be 1, okay, over negative 26, and then minus 3 root of 3 over minus 26. Okay, because they have a common denominator, so we can easily break them apart. Okay, now let me do this. So here we have a plus 1 and here we have a minus 1. So plus divided by minus gives us a minus 1 over 26. Then minus divided by minus, they cancel out. So you now have a plus. This is now plus 3 root of 3 over 26. Okay, correct. Now here right now, let's now identify. Remember, they say we should express this in the form of P plus Q root 3. Now, what does this imply? This simply means that the number attached to the root 3 is our Q. Okay? And the number that comes before is our P. So you can see here is our P. When we compare this to what we were given, we can see that our P is equal to minus 1 over 26. And then our Q is equal to the number attached to the root 3. Have you seen it here? Our Q is attached to the root 3. So this now becomes 3 over 26. And this is our solution. See you in the next video where we shall be talking about surds, mathematics in general, physics, chemistry, and all the like. Thank you and bye.